Hello students, in this mini lecture I want to discuss a little bit about vectors. The first I want to mention is that in physics we are going to be dealing with vectors and with scalars. And we have to be clear that vectors have magnitude and direction, while the scalars has only magnitude. So when we're talking about vectors, we're talking about, for example, force. We're talking about velocity. We're talking about acceleration and others. When we're talking about scalars, we're talking, for example, about mass. We're talking about speed and others. So we have to see the difference, between the vector and scalar. So when we say the mass of an object is 50 kilograms, this is a scalar because this mass have no direction. It's just the mass, it's a magnitude. Something that I want to highlight here is that in physics, when you have a physical quantity, if you don't put the units, probably that number would be meaningless. So mass equal 50 don't have any sense. You have to say that the mass of the object is 50 kilograms, 50 pounds, 50 ounces, 50 grams. So the units are very important because if not, that number by itself is going to be meaningless. Now, when you are talking about force, you can say that, for example, the force is equal to 30 newtons to the right. Or you can say that the force, right, and then I write this force as a vector with the arrow on the top, that is equal to 30 newtons, and then I'm going to say that toward the north. So it will be pointed out. Right? So this is the difference between vectors and scalars. Now, when we're working with vectors, we're going to find the components of a vector. So if we have, for example, a rectangular coordinate system here, and I have a vector f equal to 30 newtons with an angle of 40 degrees respect the horizontal. I know that if I make a projection, of this vector on the x and y axis, I will have then the x and the y components of the vector. So this here will be fx, and then here we're going to have fy, or the y component. So these fx and fy are going to be related, with the force F through one of the trigonometry ratios, right? So since fx is adjacent side to the angle of 40 degrees, I can say that fx is f cosine of the angle theta. And I can say here that fy is, since this side is opposite to the angle of 40 degrees, fy is f sine of the angle theta. So if for this angle of 40 degrees and the force F of 30 Newton, I try to find, the components of this vector, we can say that fx, right, that is f cosine of theta, would be equal to 30 newtons cosine of 40 degrees, if I put in my calculator that, you know, cosine of 40 times 30 would be equal to 22.98. So let me say that is approximately 23.0 or 23 newtons approximately. If I find out Fy, and I know that Fy is F sine of zeta, so it would be 30 newtons sine of 40 degree. So it would be sine of 40 times 30. This is equal to 19.3 newtons approximately. Now, if you want to express, uh, these components or this vector f in terms of, the components and the unit vectors, and then let me explain what the unit vectors are. So we have the coordinate system here, x, y, and then, we have here one vector of unit uh, one of magnitude 1 that is going to be the unit vector I that is in the direction of the x-axis, and we have another vector of magnitude 1 that is called the unit vector j that is in the direction of the y-axis. If we are working in 3 dimensions, then we're going to have a third unit vector that would be the unit vector k, but this is if we are working, in 3 dimensions. So if I have a z-axis here, then I'm going to have a unit vector k here. It would be a vector of magnitude 1 in the direction of the z-axis, so this is the unit vector k. So in this case, I am working in 2 dimensions, so if I want to express, this vector f in terms of, the components is in the unit vectors, I can say that f is equal to fx unit vector I plus fy unit vector a. So this will be the same that 23 newtons I plus 19.3 newtons J. Well, after explaining this part, then I want to solve some exercises, that I took from the book about operation with vectors. In my first exercise here, they give us two vectors, a vector 8. There is negative 5i minus 3a plus k, and in vector b there is 2i plus j minus 3k, and then we are asked to find a plus b. If we find a plus b, we're basically adding the vector a with the vector e, so we're adding the components, the I component, or we're going to be the different components. That means the components that have the same unit vector. So I'm going to say that in this case, a plus b will be adding the I will be negative 5 plus 2. This is I plus, and then negative 3 plus 1, because in front of this unit vector j we have a 1, so negative 3 plus 1 j plus 1 plus minus 3 k. So this would be negative 5 plus 2 is negative 3i. Negative 3 plus 1 is negative 2j, and 1 plus minus 3 would be negative 2k. So this is how I do the addition of the vector A with the vector B. if I have to find out the difference between vector A and vector B, so I will find vector A minus vector B. What I'm going to do is just to find the difference between the different components, right? So I'm going to have in this case minus 5 minus 2, because we're subtracting the I component, of vector B from A. All this is I plus, and then now we do the same with the J. So we say minus 3 minus 1 J, right? And then we do the same with the K, so we say plus 1 minus negative 3 K. So this would be negative 5 minus 2, it would be negative 7I. Negative 3 minus 1 would be negative 4J. And 1 minus negative 3 would be 1 plus 3, so it would be plus 2K. Oh, sorry, this is 1 minus negative 3, so this is 1 plus 3, so 1 plus 3 is 4. Bye-bye. So the final answer here is minus 7I minus 4A plus 4K, because it's 1 minus negative 3, so 1 minus negative 3 is 1 plus 3, so it's 4. And for example, suppose they ask you to find, in this case, 2A minus 3B. So when you multiply a scalar times a vector, you multiply every component of the vector times that scalar. So if I have 2A minus 3B, what I'm doing is basically multiplying the vector A times 2, the vector B times 3. So I will multiply and find the difference at the same time. So this would be 2, that is the scalar, times the I component, the vector A, so it's 2 times negative 5. I have as subtractions, so I'm going to say minus, and then I3, this is scalar, the multiply the vector B times 2, there is the I component of the vector B, so minus 3 times 2, or this is I. Plus, now we do the same for J, so I say 2 times negative 3 minus 3 times the value here is 1, so minus 3 times 1 J. And then we go over the K, so we say 2 times, this is 1 here, so 1 minus, and then I say negative 3, 3, sorry, because it's 3 what multiplies the vector B, so 3 times negative 3. There is the value of the K, so negative 3 times negative 3 here. This is K. So it would be 2 times negative 5, this is negative 10 minus 6, because negative 3 times 2 is negative 6I, plus 2 times negative 3 is negative 6, minus 3 times 1 is minus 3, J, plus, so 2 times 1 is 2, negative 3 times negative 3 is positive 9, K. So now we have minus 10 minus 6 is minus 16I, minus 6 minus 3 is minus 9J, sorry, J. This is J here, let me erase. And then this is a 16, remember. And then 2 plus 9 is 11, K. And we did it. So we multiply each vector by the scalar, and we found the difference between both. The next exercise is an exercise where they give us a vector and they ask you to find the unit vector that is parallel to the given vector. So I have a vector A here, that is equal to 2.0i plus 4.0j plus 4.0k. And the question here is to find a unit vector parallel to vector 8. So to find the unit vector that is parallel to A, I have to divide the vector A by x magnitude. So the first that I have to do is to find the magnitude of the vector A is the square root of the I component square, so 2.0 square, plus the j component square, 4.0 square, plus the z component square, so 4.0 square. So it would be here the square root of 4.0 plus 16.0 plus 16.0. So this is the square root of 36.0. And also it would be 6.0. So once I have the magnitude of the vector A, to find the unit vector, what I have to do is to divide each component of the vector A by the magnitude. So I have 2.0i divided by 6.0 plus 4.0j divided by 6.0 plus 4.0k divided by 6.0. So 2 over 6 would be 1/3. I, 4 over 6 would be 2/3 j, and 4 over 6 would be 2/3 k. So this vector we have over here is the unit vector that is parallel to the vector A. Okay, now in my next exercise, they give us 3 vectors, and then they also give us so in my next exercise I'm going to solve a problem where we have 3 vectors a, b, c, and 2 constants, and I want to find the value of the constants, right? The problem is just like this. I say like we have a vector A, there is 2.0i plus 3.08. We have a vector B that is 1.0i plus 5.08. And we have a vector C here. There is negative 1.0i plus 3.08. So if I multiply a constant C1 times my vector A plus a constant C2 times my vector B, that should be equal to my vector C. So what are we doing here? We'll say, okay, yeah, we'll multiply then C1 times I, so I will get C1 times 2.0 I plus C1 times 3.0 J, plus I will multiply C2 times the vector B, so I say C2 times 1.0 I plus C2 times 5.08, and this will be equal to my vector C, that is negative 1.0i plus 3.08. So now I will say that C1 and you're just taking the I components, right? Writing an equation with the I components, I can say that 2.0 times C1 plus In this case, 1.0 times C2 is equal to negative 1.0, making this equal to the component of the vector C that I have on the right side, the I component. So I can say now with the J components, that 3.0 times C1 plus 5.0 times C2 equals to 3.0. So now I'm going to say that C1 is equal to X and that C2 is equal to Y. I have a system of equations that I will solve. I will do it using determinants, right? So I'm going to say that the determinant D here will be equal to 2.0, 1.0, 3.0 here, 5.0. If I find the determinant, it would be 10 minus 3, that would be 7.0. I will find now the x. So I hold, the Cramer rule. So I am going to find the x. So to find the x, I replace the C1 column by these values I have on the right side. So say negative 1 and 3.0, negative 1.0 and 3.0. And then 1.0 here and 5.0 here. So when I calculate the determinant, I have negative 5 minus 3, so this would be negative 8.0. And then I will find the y, and when I find the y, I will replace the y column, or the column of the C2 with these values I have on the right side here. So say 2.0, 3.0, and then negative 1.0 and 3.0 here. And then I will find the value of this determinant. So this is 6 minus negative 3, so it will be 9.0. So now I can say that x, that is the same, that C1, is dx over d, so is negative 8 over 7. And then I say that y, that is the same, that the constant C2 is the same, that dy over d, so this is the same as 9 over 7. So I found, the values of the constant C1 and C2, so that C1 times the vector A plus C2 times the vector B is equal to the vector C. My next exercise is an exercise where we're going to find the angle between two vectors. So suppose we have the vectors A, that is negative 2i plus j plus 2k, and we have a vector B, there is 3i minus 6j plus 2k. Well, if we have to find the angle phi between these two vectors, of course we know that the angle phi between the vectors will be equal to the product of the vector A times, vector B over the product of the magnitudes of the vectors A times B. So the first will be to find the magnitude of the vector A. That would be negative 2 squared plus 1 squared plus 2 squared. So this would be a square root of 9, 1 is 3. We find the magnitude of the vector B. That is 3 squared plus minus 6 squared plus 2 squared. What is equal to square root of 49 here, so it's equal to 7, and then I will find the product of A and B. So the product is equal to negative 2 times 3 plus 1 times negative 6 plus 2 times 2. So this would be equal to negative 6 minus 6 plus 4, so it will be negative 8. So now I know that the cosine of phi will be equal to negative 8 over 3 times 7. So it's negative 8 over 21. So the angle phi is equal to the cosine inverse of negative 8 over 21. So this would be equal to 112.39 degrees. So this is the angle between, my vectors. In my next problem, I have a vector A, and I will find the first derivative respect the time of this vector A, and then I will try to show that the vector A, the dot product of, that means that the vector A and its first derivative, are perpendicular. So we have to demonstrate that the dot product of these vectors is equal to 0. So we have a vector A here, and this vector A is I cosine of Wt plus J sine of Wt. So W is a constant, and when I find now dA dt, this is the same defined to d of I cosine of Wt plus J sine of Wt dt. So the first derivative of the cosine of Wt would be negative sine of Wt times W. So this would be negative I, of course, the unit vector. So the derivative of the cosine is negative cosine, and the derivative of Wt using the chain rule is going to be W. So negative I W cosine of Wt, and then the derivative of the sine, sorry, my mistake, derivative of cosine is minus sine, so this is sine here. So this is negative I W sine of Wt, and the derivative of the sine is cosine. So the derivative of sine Wt will be W times cosine Wt. So plus J W cosine of Wt. So this is my, in this case, my derivative, the derivative of the vector A, negative I W sine of Wt plus J W cosine of Wt. Now, to find if these vectors, the vector A and its derivative, are perpendicular, we must find the dot product between them. So we have to say here that the vector A, the product of the vector A with its derivative, respect t. If I want to find, this is a product, of course, we have to multiply the I components plus the J components. So we're going to say that this is equal to, in this case, cosine of Wt times negative W sine of Wt plus, now we multiply sine of Wt times W cosine of Wt. So this would be negative W cosine of Wt times sine of Wt. It doesn't matter the order. I'm going to say sine Wt cosine of Wt. Each one we can put in parentheses, Wt, the argument of the sine and cosine functions or not. So we can say now plus W, this W here, times the sine of WT cosine of WT. Of course, when you look at these two expressions, are the same expression with different signs, so this is equal to 0. So here you have the product of these vectors is equal to 0. So when the dot product is 0, we can say that the vectors are perpendicular. In my next exercise, we have three vectors. There are some nums and some of those vectors, So we have a vector A that is equal to 5.0i minus 2.0a plus 3.0k. We have a vector B here that is equal to bxi plus 3.0a plus bzk. And then we have a vector C that is the cross product of vector A and vector B, and this cross product of vector A and vector B will be equal to 2.0j plus zzk. So we have to find Bx, Bz, and Cz. So if I have that the cross product of the vector A and B is equal to the vector C, right? And I know that the cross product of vector A and B is equal to, let us write this as, as a determinant here. So this would be I, J, K, and then 5.0 bx, negative 2.0, 3.0. These are just the components of the vector A, vector B, bx, 3.0, and bz. And that would be equal to C. But let us solve first this determinant. So we have here I times, so we have now a 2 by 2 determinant that is going to be, canceling this column with this row. We get these values here. So negative 2.0, these entries, right? 3.0. This one is also 3.0. This is BZ minus. Then we have the J. And then we are taking, if we are now analyzing for the determinant for this second entry, we are going to be eliminating this row and this column. So we have a determinant of 2 by 2 with 5.0 bx, 3.0, and bz. Plus k, and then here we have now, so we are taking these four values of 5.0, negative 2.0, bx, and 3.0. So when I solve those determinants, right, and I'm gonna do this, and I'm gonna convert this process, in something very difficult. So solving the determinants, I'm gonna get I. This would be negative 2.0 b z minus 9.0 minus j times 5.0 bz minus 3.0 ex plus k times 15.0 plus 2 bx. This is equal to the vector c. So we can say now here that if this vector c, is 0i plus 2.0a plus czk, now making the I is equal here, we can say that negative 2.0 bc minus 9.0 is equal to 0i, so it's equal to 0. This is one equation. We have that if negative 5.0 bz plus 3.0 ex, this negative sign is reversing the signs inside here, equal 2.0. This is my second equation. And I have another equation. There is 15.0 plus 2.0 bx equals cz. Solving this first equation here, I get bz is 9.0 over negative 2.0. So bz will be equals to negative 4.5. Now we replace this bz here by negative 4.5 or by negative 9 over 2. So I say negative 5.0 times negative 9 over 2 plus 3.0 ex equals 2.0. So this negative 5.0 times negative 9 over 2 will be negative 45 over 2. I mean positive 45 over 2. Because negative to negative positive plus 3.0 bx equal 2.0. So now I will be subtracting 45 over 2 from both sides, right? So I will get here the 3.0 x is 2.0 minus 45 over 2. So this would be let me double check something here with a sign. Yeah, that's fine. So this will be 3.0 x. This here will be 4.0 minus 45 over 2. So this would be 3.0 x equals negative 41 over 2. And then dividing by 3, we get a vx is equal to negative 41 over 6. Negative 41 over 6 would be 6.83. Negative 6.83. So this would be the value of Vx, and now we can replace, this Bx over here by negative 41 over 6 or by negative 6.83 to find Zz. So we say 15.0 here plus 2.0 times negative 41 over 6 equals Zz. So this would be here now 15.0 plus negative 41 over 6 equals z. Sorry, it's 41 over 3 because 2 and 6 here cancel out. You cancel 2 with the 6, so you get 3 here in the denominator, right? So this denominator here is 3. So now you have 45 minus 41 over 3 where is CC? So CC is equal to 4 over 3. So this is approximately 1.3. So we found the values of VC, we found the value of VX, and we found the value of CC. It was a very interesting exercise this one. I have one more exercise here for you guys. As part of this mini lecture, the last exercise I want to show you is an exercise where we want to find the unit vector, the point halfway between the two position vectors, two given position vectors. So if I have two position vectors here that are vector A equal to 4i plus 2j, and the vector B here that is equal to negative I plus 3j plus 2k, I want to find the unit vector that point halfway between the position vectors A and B. So basically, this unit vector that point halfway between the position vectors is the vector that bisects, the vector A and vector B. So you want to find the vector that bisects, bisects, let me erase here, bisects vector A and B. This vector will be the magnitude of A times the vector B plus the magnitude of the vector B times the vector A. This is how you find the vector that bisects vector A and B. So you find first the magnitude of the vector A. So you say that this is the square root of 4 squared plus 2 squared. So this is 16 plus 4 is the square root of 20, so it's 2 square root of 5, right? And then now here you find the vector B, the magnitude of the vector B, that is the square root of negative 1 squared plus 3 squared plus 2 squared. So this would be 1 plus 9 plus 4, so it would be a square root of 14. Once you know the magnitude of the vector A and vector B, following this expression here, you can say that the vector that bisects vector A and vector B is equal to vector A, magnitude vector A, that is 2 square root of 5 times vector B, so vector B is negative I plus 3j plus 2k, plus now the magnitude of the vector B, that is square root of 14 times vector A, there is 4i plus 2j. So if I evaluate these square roots and multiply, using distributive property, each component by the scalar, we're going to have at the end that this will be equal to 10 well, this would be just multiplying and combining. So let me multiply first. It will be negative 4.47i plus 13.41 j plus 8.94k plus multiplying square root of 14 times 4i will be 14.96i, and square root of 14 times 2j will be 7.48j. We combine the similar terms just to say in some way this, right? That means the same components with the same unit vectors, and we get 10.49i plus 20.89j plus 8.94k. This vector we have here is the vector that bisects the vector A and vector B. But now, if I want to find a unit vector to find the unit vector that bisects those vectors, to find the unit vector that bisects A and B, we have to find the magnitude of this vector. So we can say that the magnitude of the vector that bisects A and B is the square root of 10.49 squared plus 20.89 squared plus 8.94 squared. That would be equal to 25.03. And then what I have to do is to divide each component of the vector that bisects the vectors A and B by its magnitude to find the unit vector that bisects. So I would be now dividing, so let's say 10.49i divided by 25.03 plus 20.89j divided by 25.03 plus 8.94k divided by 25.03. So this would be now here 0.42i plus 0.83k plus 0.36. Sorry, this is j here. Sorry, j plus 0.36k. And this vector that we have here is a unit vector. This is a unit vector, and is the unit vector that bisects the vector A and B. This vector over here is the vector that bisects the vectors A and B. This is the unit vector that bisects the vectors A and B. So those were some exercises, that I prepare about vectors to explain this topic, in this very quick mini lecture. I hope that with this exercise you're going to understand better this section of vectors. And then in next classes of physics, we're going to move toward now motion in one direction, that means along a straight line, or motion in two dimensions. So we're going to be preparing another lecture, mini lecture about those topics. Thank you for your attention. Have a good day.